Hello class, here it's Mr. Kablan here again. And what we're going to do for today is we're going to revisit slope. You discovered this in grade 9 as rate of change. So we're now going to connect the two together. And one of the things that I want you to have again in front of you, again, are your notes, as well as your calculator, a pencil, and a ruler would be beneficial for today's lesson as well. All right, so let's get straight to it. So as I said before, this is going to be basically a review of what you spent a lot of time with in grade 9. And basically what we're going to understand here is that we're going to look at what's called a linear relation. And that's going to be actually the focus of this entire chapter here. So when we're looking at linear relation, that means when you're taking a look at an equation or a table of values, what you're what you're going to wind up seeing there is going to be a straight line there. So what we're going to do here is we're going to learn how to, we're going to revisit how to calculate slope and relate it back to rate of change here. And the connection between where you left off in grade 9 and what we're going to see in this chapter here is we're now understanding that rate of change and slope are exactly the same thing here. All right, so first things first, we're going to revisit how to calculate slope using what's called a rate triangle. And what you see here for the first example is a dotted line connecting a set of dots at M, okay, and connecting it to the N there. Now, what a rate triangle is a right triangle that's in between the 2 points that you can see there, which is M and N. Okay, and all we're going to do here is to count the number of squares between the points that we're connecting here. So starting off with M to N here, we're going to first calculate what's called the rise, okay, which is the number of boxes that are going up and down. Okay, and the way you do that is if you take a look at the M here and you start from that dot, you're going to count the number of boxes from that dot to the corner of the triangle. So if you take a look at that dot at M, if you count the number of boxes, okay, there are 6 boxes there, all right? So that's going to be the rise. So let's fill in the table there and put the rise here as 6. So the next part here is the run, okay? And the way you count that is if you take a look at the N here, okay, you're going to count the number of boxes from the N to the corner of the triangle. So when you do that, okay, you will see that there's 3 there, okay? So what we have here is a rise of 6 and a run of 3. And the formula for the slope of a line using a rate triangle is rise over run. So what we have here will be 6 over 3. Okay, so using your fraction key there, if you punch in 6, fraction key 3, that will reduce to a whole number in this case, which is 2. Okay, so let's take a look at x to y here. And we're going to do the exact same thing. We're going to connect those 2 points with a rate triangle. Okay, so we're going to do the exact same thing. We're going to look at the rise. So starting from the x here, if you count the number of boxes from the x to the corner, okay, again, we have 6 boxes there. And from the y to the corner of the rate triangle, we will get a run of 3. Okay, so you can see here we get the exact same numbers, okay, and that will give us 2. Now, for example, if you choose any of those points there, x, m, y, or n, okay, if you connect them with a rate triangle, you will get the exact same slope. Okay, so for example, if I created a rate triangle between x and, let's say, y, x and n, okay, you're going to see that we will get the same slope as our final answer here. We might get different numbers for the rise and the run, but when you reduce them, you will get the exact same slope. And that's the idea for this particular exercise there. All right. So it says here, what do you notice about the slopes of these line segments? As you can see, even though we have 2 different line segments, the slopes are exactly the same. So if you take a look at the number of blocks on the top of the screen there, all it tells us here is that every block here is going up by 2. So if you look at diagram 1 and diagram 2, you're going from 1 block to 3 blocks. Okay, if you're looking at diagram 2 to diagram 3, you notice we're going from 3 to 5 blocks. Okay, and then from 3 to 4, we're going from 5 to 7. And then from diagram 4 to 5, we're going from 7 blocks to 9 blocks. Okay, so that's just an example of how we use that for this particular example there. All right, so the next thing we're going to do here is we're going to actually calculate the rate of change by constructing a table of values. Okay, and then from there, looking at the rate of change by looking at the y values. Okay, and the way we do this is exactly the same way that we did with the previous lesson, where we substituted or replaced each of those x values in wherever there's an x here. So I'm going to do the first couple of examples for you. So for the first one over here, all I'm going to do here is to take that x of 0 and then replace the x in the equation. Okay, so if you take a look at what I have here, I have y equals 2x plus 5. So all I'm going to do in the next step here is replace 0 in for x and put brackets around it. Okay, and if you punch that in your calculator, 2, okay, and in brackets 0 plus 5, that should give you 5 there. Okay, if you didn't get that, okay, redo it because you probably did a misstep there. But the main thing that I want you to see here is that anytime you replace a variable with a number, okay, always put brackets around it. Okay, your calculator will do all the work for you there. Okay, so we're going to do the same thing for 1. Okay, in this case here, I'm now going to replace the x here with 1. Okay, and just like the previous step here, okay, put brackets around the 1. Okay, so when I go 2 brackets 1 and I go plus 5, that will give me 7. All right, and we'll do one more together here. Okay, so notice I'm doing the exact same thing. I'm just replacing the x there with the number that's in the table of values. Okay, so we have 2 and in brackets 2 plus 5, and what we have here is 9. Okay, so I'll stop there. Now, to find the rate of change here, you probably notice that these numbers here, 5, 7, and 9, are all going up here by 2. Okay, so we can finish the rest here by simply just adding 2 from the previous number. So if we add 2 to 9, that's going to give us 11. And when we add 2 to 11, that gives me 13. Okay, so if you see that the pattern of these numbers is all going up at the same number, okay, guess what? You have just figured out how to calculate the rate of change. Now, what I want to show you here is how to calculate the rate of change, okay, using what are called successive y values. And all we're going to do here is to subtract the successive y values, okay? And the way we do that is to take the number, for example, 5, and then subtract it from 7. So what we have here is 7 minus 5, which gives me 2. Okay, next one here, we're going to take the 7, subtract it from the 9, okay, which gives me 2. Okay, and as you can see, all I'm doing is subtracting the previous number from the one right after it. Okay, and again, all of these are 2. Now, as I said before, some of you could probably see that these numbers here are going up by 2. Okay, and that's just another way to calculate rate of change. Now, you're probably asking, when do we have to subtract? When is a good time to subtract the successive y values? If you don't see the pattern right away, that's probably the best time to do it. Okay, but what's also going to be a great way to use the subtraction of successive y values is when you have negative numbers. Okay, so if you have negative numbers, it's a nice time to do it. Okay. All right, so that's using a table of values by constructing the table of values and to calculate the rate of change. So the next thing we're going to do here is we're going to do the same thing. This time, we're going to use the table of values, okay? And then from there, use the table of values to graph the line, okay? So that's our very first step, okay? So what we're going to do for this case here is we're going to approach it the exact same way from the previous example by substituting or replacing each of those x values into the equation. So start with the first one here. All I'm going to do here is to take the equation, y equals negative 3x plus 2, and I'm going to replace x with those numbers. So for the first one here, I'm going to replace the negative 2 in for the x, and just like we did with the previous example, I'm going to put brackets around it. All right, so punch in negative 3, okay, that plus minus key I introduced you to in the last lesson. Okay, and when you do that, open up a set of brackets and punch in negative 2, and then close brackets. Okay, and then from there, add 2. So if you did that correctly there, that's going to become 8. Okay, so we're going to do that for all the examples here. So we're going to take the negative 1, replace it in for the x. And if you put that in your calculator carefully, you should get there 5. Okay, next one over here, we're going to put 0 in for the x. That will give me 2. Okay. So as you can see there, what I want you to just notice that all we've done here is replace the values in for x, put it into the equation, and then solve, and then it gave us the y here. So for the next two here, okay, again, we're going to take the 1 here and replace it in for the x. That will give me negative 1. And last but not least here, if you put in the 2 in for the x, that will give you -4 there. Okay, so if you can try that again, if you do that in your on a side there, you should get a -4. Now that's our very first step there. So all we've done so far is we've taken each value of the x and then put it into the equation, and then came up with the y. So in order for us to graph the line, if you take a look at your graph there, what we want to do here is to express each of these as a point. So the first point here is -2 and 8. So the way we graph that is we're going to go left 2 and then up 8, like that. Okay. So what I've done there is that starting from the middle of the graph here, 0, 0, we're going to go left 2 and then up 8. So that next one here is -1, 5. So from the center, you're going to go left 1 and up 5. Okay, 0, 2. Okay, that tells us that we're not going to move left or right. We're just going to go up 2. Next one here is 1 and -1. So we're going to go right 1, down 1. And the next one, last one here is we're going to go 2, -4. So that's right 2, down 4. Okay, and then from here, we're going to connect those 5 dots with a straight line that goes straight through. Okay, and don't forget to label the line there. Okay, so that's our very first step. So again, what we did here is we used the equation, and we took each of those x values and then substituted into the equation to get the y. And then you can see here that each of those numbers, the x and the y respectively, create what's called an ordered pair, which you were introduced to back in grade 9. Okay, and then from there, when we graph it, you can see that what we have here are 5 points which construct the straight line going down to the right. So the next thing we're going to do here, it says pick any 2 points from the line, then find the slope. And what do you notice about this and the equation? So what we're going to do here is we're going to randomly pick 2 points here. Now I've just set these up over here. Again, I've randomly picked the second point here, okay, and the last point. Now you notice that I have there in blue, it says since the line falls to the right, okay, the slope is negative. Okay, so you might want to put a star beside that one because again, as I said before, anytime you see a line that's going down the right, it's always going to be negative here. Okay, so when you do that, what's going to happen is we're going to count the number of boxes from those 2 points. So starting off with the rise here, starting from the red dot, if you count the number of boxes from the red dot to the corner of the triangle, okay, you will get a rise there of 9. Okay, and from here, for the run here from the dot, if you count the number of boxes from the dot to the edge over here, that's going to give us 3. So what we have here is a rise of 9 over a run of 3. Now you notice I have a negative in front there because again, as I said before, this is a line that's falling down to the right. So anytime you see a line that is going down to the right, okay, don't forget to put that negative sign in front. Now if you punch in the negative key, that plus minus key I introduced you to, okay, and then 9, and then press fraction key, and then press 3, that will reduce to -3. All right. Now, for the second part of the question here, says, what do you notice about this and the equation? Okay, I want you to notice here that the slope of -3, okay, is also located in front of the x here. So what that means here is that the slope of any equation can simply be found by looking at the x and looking at the number that's attached to it. Okay, and that goes for any equation. So whatever number is in front of that x here, or that's attached to it, that is always going to be the slope. All right, so the last thing we're going to do here is we're actually going to take a look at a word problem. And we're going to start this from scratch here. So it says here, Abdul earns $12 per hour working at a video store. And what we want to do here again is just to take a look at how many hours this person works and how much this person is getting paid. Okay, so the way we're going to do that is that if you take a look at the number of hours, you're simply just going to take all those number of hours and then multiply it by how much this person gets paid. So for the first one over here, okay, what we're going to do here is we're going to take the $12 and then multiply it by 0. Okay, so he didn't work anything, so it just makes sense that 12 times 0, that's going to give me 0. All right, next one here, we're going to take the 1 and we're going to multiply that by 12. So that gives me 12. Okay, if you take a look at the 2 here, 12 times 2 is 24. Okay, and as you can see, 12 times 3, that gives me 36. 12 times 4 gives me 48. And last but not least, 12 times 5 gives me 60. All right, so the next thing what we're going to do here is we're now going to take a look at the pay here and look at the rate of change. And a couple ways that you can do this before we actually break it down. If you take a look at the pay here, as you go down the pay column, if you notice the numbers are all going up by 12, okay, that's just another way to calculate the rate of change. Because remember, the rate of change, again, for linear relations, is always going to be the pattern. Okay, so that's one way to do it. Another way you can do it, again, is to subtract the successive y values, which in this case is the pay. So for the first one here, we have 12 minus 0, which gives me 12. Next one here will be 24 minus 12. Well, that gives me 12 as well. Okay, and you can see here 36 minus 24. Okay, that gives me 12. Okay, so you can see that all these numbers here are all going to be 12 here. So the rate of change here is going to be 12. All right, so again, what we've done here, we've taken a table, we've completed it, we've found the rate of change. So the next thing that we're going to do here is we're going to graph it. Okay, and the way we graph this, just like we did with the previous example, is we're going to use, take each of those numbers, the number of hours and pay, and just express them as coordinates. Okay, so the way we label this is that on the bottom is the number of hours, and the numbers going up and down is the pay. Okay, and we're going to just title it as number of hours versus pay. So starting off the point 0, 0, okay, we're just going to put that in the bottom left-hand corner. Next point we have here is 1 and 12. So we're going to go right 1 and then up to where the 12 is. Now, before we proceed to the next set of points, notice that the numbers going up and down are all going up by 6. So just be careful when you're plotting the points. Okay, next one here is 2 and 24. So we're going to go right 2 and up 24. Next one here is right 3 and up 36. Next one here is right 4 up and 48. And last but not least, what we have here is right 5 and up 60. Okay, and connect those points with a straight line. All right, so now that what we have here is a straight line, this graph models the relationship for this problem here. So it says for part D, it says pick any 2 points and calculate the slope. And what do you notice about the slope and your answer? Okay, so again, we're going to use rise over run. And the way I'm going to do this over here is I'm going to take the first and the last point. Now, what's important for this calculation, and I just want you to be careful with this one, is that when we do rise over run, okay, we have to focus on the numbers that are in the graph over here. So if you take a look at the rise, notice what the rise is. You're looking at the numbers, okay, that make up the pay, which is on the left side over here. Okay, so what we're going to do here is that just remember that each box here, okay, represents 6. So the best way to do this is if you take a look at the green line that I'm using as a guide over here. If I go up, okay, to the red dot and then it'll go across, you notice it meets at 60. Okay, guess what? That's going to be the rise. So the rise here is 60. Now the run here, we're just going, you're going to see here that if you take a look at this green line, okay, when I go across and I go to look at the corner here, notice that what I have there is the number 5. So that will be the run. So what we have here will be a rise of 60 and a run of 5, which gives us a slope here of 12. Okay, so you can see here that the slope and answer from B are exactly the same. So this just wraps up what I mentioned, is that slope and rate of change are exactly the same thing. So for the last part here, just to look at an alternate solution. Okay, so the way we're going to do the rise over run, okay, is that if you take a look at the spaces, as I said before, there's 10 spaces. So the way we look at this here is if you take a look at the 10 spaces over here, okay, and you, as I said before, you notice each of those spaces are going up by 6. Okay, what we're going to do here is understand that since there are 10 spaces and each one of them is 6, well, the way we do that is to take the 10 and then multiply it there by 6 there. Okay, so that's just another way to do it. So that will give us a rise of 60. Okay, and the run is exactly the same way here. There's 5 spaces. So what we have here will be 60 over 5, which will give us the same answer there. All right. So like I said, I presented the alternate solution just so, again, people have a different way of understanding things. So I'm just presenting you with just an alternate way to do it. All right. Okay, so that wraps up this particular lesson here. So if you turn to your set of questions, Okay, you can start working on that. If you have the textbook, okay, these are the pages from it. If you have the workbook, you can work on the questions um, that were attached as an attachment there. All right, and I will see you in the next lesson.